Two resistors, R1 and R2, are connected in parallel. For part A, derive a simpler expression for the equivalent resistance of these two resistors by finding a common denominator. So, the formula for resistors in parallel is 1 over Rp is equal to 1 over R1 plus 1 over R2. So the common denominator in this case will just be found by multiplying those two denominators together. Just like 1 over 3 and 1 over 5, the common denominator is found by multiplying the 3 and the 5 to get 15. So, the common denominator is R1, R2. So what goes in the numerator? Well, obviously you can see that to make this work, the first fraction would have to have an R2 in the numerator, and the second fraction would have to have an R1 in the denominator. So this becomes R2 plus R1, or I can just reverse it and say R1 plus R2 over R1 times R2. Since that is equal to 1 over Rp, I can take the reciprocal of this, which will say that the resistance of two resistors in parallel is equal to R1 times R2 over R1 plus R2. So that works if you have two resistors in parallel. What about if you have three resistors in parallel? Does it work? And we can answer this question just by focusing on the units. In other words, we're trying to say, does Rp equal R1, R2, R3 over R1 plus R2 plus R3? Is that formula valid? If you look at the formula we just derived right here, resistance should be measured in ohms, and we have in the numerator we have units of ohms times ohms, or ohms squared. In the denominator we have units of ohms plus ohms, which is just going to be units of ohms. So ohms squared over ohms is equal to ohms, so that's a valid formula because the units match. In this formula, we would have in the numerator, we have three resistances multiplied together, which would give units of ohms cubed, and in the denominator we still have, when we're adding three resistances together, it's still just units of ohms. That is equal to units of ohms squared, which is not a unit of resistance. It's a unit of resistance squared. So that means that this formula would not work, and we'd have to say we cannot use the formula for more than two resistors in parallel.